All right, let's get right into it. Deep down in the Atlantic Ocean, there's this massive current that basically acts like the planet's circulatory system. For thousands of years, it's been this steady, reliable force that shapes our weather, our climate, pretty much everything. But what if it wasn't so reliable? New research is suggesting this whole system might be creeping towards a tipping point. I know, it sounds like something straight out of a disaster movie, right? But this is a question that climate scientists are taking very, very seriously. Because if this current were to suddenly shut down, the fallout would be global, and it would happen fast.
So the system we're talking about here is called the Atlantic Meridional Overturning Circulation, or AMOC for short, which is way easier to say. The best way to picture it is as a giant heat conveyor belt. It literally pulls warm, salty water from the tropics all the way up to the North Atlantic. There, the water cools off, gets super dense, and sinks deep into the ocean before heading back south. This whole circulation is absolutely fundamental to the climate we all live in.
Now you might be thinking this idea of a sudden climate change is all just some futuristic theory. But here's the thing, it's not. To figure out what could happen, scientists are actually looking back in time, way back, to the last ice age, where they found proof that our climate system isn't always so stable.
Yeah, when you drill down into the Greenland ice sheet, the ice cores tell this wild story. Scientists found 25 separate times when the climate didn't just warm up a little bit, it spiked, and spiked fast. It shows the whole system can kind of flicker between different states, and it has, over and over again.
And sometimes, these flickers were tied to something even bigger. Geologists started finding these weird layers of rock fragments on the seafloor, carried there by what you can only describe as massive armadas of icebergs. These Heinrich events dumped incredible amounts of fresh water into the ocean. And that's the key, because fresh water is lighter than salt water, and it can basically clog up the engine of the AMOC, stopping that crucial sinking motion.
And when those past slowdowns happened, the effects were felt all over the world. It wasn't just a local thing. The evidence is totally clear. When that Atlantic heat conveyor slowed down, North America and Europe got colder. Rainfall patterns went haywire across the tropics, and Antarctica actually warmed up. It was a complete reorganization of the global climate, all triggered by that one change up in the North Atlantic.
Okay, so we know it's happened before. The big question is, could it happen again in our world? For years, that was mostly theoretical. But now, for the very first time, a team of scientists has actually managed to simulate a full AMOC collapse in a state-of-the-art climate model.
So how on earth did they do it? Well, it was a massive, massive job for a supercomputer. They started with a stable climate model, and then they just began to slowly add fresh water into the North Atlantic, kind of like simulating melting ice sheets. Then they just let the model run for the equivalent of more than 2,000 years.
And this is what they found. Just focus on the main graph here. It shows the strength of the current. For over 1,700 years in the model, you can see it gradually getting weaker as more fresh water gets added. But then, it hits a cliff. In the span of a single century, the circulation just completely crashes down to almost zero. The model shows it doesn't just fade away, it hits a tipping point and collapses, abruptly.
And this is why this is such a huge deal. The simulation proves that an AMOC tipping point isn't just some abstract idea from a simplified model. It can actually happen in a complex, top-of-the-line global climate model that has all the pieces: the atmosphere, the oceans, the ice. Scientifically speaking, this is a real game changer. All right, so the model shows a collapse is possible. What would that actually mean for us, for the planet? Well, the simulation gives us a pretty chilling preview, and the word catastrophic doesn't even begin to cover it. The first thing that happens is a total reorganization of the planet's heat. You shut down that heat conveyor, and suddenly the northern hemisphere gets plunged into a deep cold, while the southern hemisphere starts to warm up because it's no longer sending all that heat north. You get this crazy seesaw effect between the two halves of the planet. And the cooling wouldn't be gradual. It would be shockingly fast. The model predicted that for a city like Bergen, Norway, February temperatures would drop by 3.5 degrees Celsius per decade. Just to put that into perspective, that is more than 15 times faster than the speed of our current global warming. Think about that. No society on Earth could possibly adapt to a change that fast. And the impacts ripple out way beyond the North Atlantic. The collapse would completely mess with the tropical rain belt. For the Amazon rainforest, the simulation shows the seasons would literally flip. The dry season becomes the wet season, the wet becomes the dry. A change like that would threaten the entire critical ecosystem with collapse. If you live on the coast, the threat is enormous.
A weaker AMOC actually changes the physics of the ocean's surface. The model shows parts of the U.S. East Coast could see sea levels rise by over 70 centimeters. That's more than 2 feet. And this is on top of the rise we're already getting from melting ice sheets.
And all that cooling up north, it would get supercharged by a massive expansion of sea ice. You can see it in the map here. The winter ice edge would stretch way farther south, down to the same latitude as London or Vancouver. This giant sheet of white ice would reflect more sunlight back into space, creating this powerful feedback loop that just locks in the cold.
So a future like that is obviously something we need to avoid no matter what. Which brings us to the next massive question. If we're actually getting close to this tipping point, would we even know it? Well, the same study also identified a potential early warning signal.
They call it FOVS. Now, you don't need to worry about the technical name. All you need to know is that it's a way of measuring the flow of fresh water way down at the southern end of the Atlantic. And they found that this one measurement is a really good indicator for the stability of the entire AMOC system.
And here is the absolute key. In their simulation, as the AMOC got weaker and weaker, this FOS value kept dropping until it hit a very clear minimum point. And that minimum, that was the point of no return. Once the system crossed that line, the collapse was locked in. It was unavoidable. And this is where things get a little unsettling. When the scientists looked at the best real-world data we have right now, they found that this same value, FOVS, is already on a downward trend. Now, that does not mean a collapse is about to happen tomorrow, but it does suggest that the real-world AMOC is moving in the direction of that tipping point they found in the model. So you have a study that says a collapse is physically possible, and a key indicator that's trending in a worrying direction. As you can imagine, this has kicked off an intense debate among scientists about what this all means and, how much we should be freaking out.
On one side, you have scientists like Nicholas Foucault who are more cautious. His take is basically that yes, this paper is important, but the overall likelihood of a collapse is still low. He points out that these long-term projections have huge uncertainties, and we're still figuring a lot of this stuff out.
But on the other side, you have experts like Stefan Ramstorff who are deeply alarmed. He calls the results quite shocking. And for him, it's not about predicting a certainty, it's about risk. And as he says, when the consequences are this unbelievably severe, even a 10% chance of an AMOC collapse would be far too high. And that's really where this leaves us. This new science is a stark warning. It basically confirms that a tipping point for the Atlantic circulation isn't just a movie plot. It's a real feature of our climate system. So the debate is no longer about if it can happen. The debate now is how likely it is and how soon. Which leaves all of us with that one critical question. How close are we to the edge?